Hi, my name's Julian Wood, and I'm a Senior Developer Advocate here at AWS Serverless. I work with builders and developers to help them understand how best to build serverless applications, as well as being their voices internally to make sure we're building the best serverless products and features. I've been using and talking about serverless for a number of years, helping the world fall in love with serverless just as I have. Feel free to contact me anytime with your serverless questions, whether you have questions from today or other general questions around serverless development. Easiest is via Twitter at Julian_Wood. So, what are we going to be talking about today? We're going to look at observability, dive into what it means, why it's important, and how it has evolved from monitoring. I go through the different components of observability, metrics, logging, alerting, and tracing, and explore the AWS services involved and some best practices. I'll then show how you can combine and correlate the telemetry you've gathered for troubleshooting and answering questions. And then I'll also be showing you some of the exciting new serverless features to help with observability. There's a lot to cover with observability, certainly more than this talk can fit in, so I've included a number of links with QR codes you can use to learn even more. When we talk about a serverless application, we're talking about the actions of an event-driven application. An event source, which could be a change in something, change in data, change in resource state, or an event can also be a request to an HTTP endpoint. This event then causes a Lambda function to run, which does some processing on the event. The function typically comprises a small, single-purpose piece of code and can be written in a number of languages provided by the platform, or you can bring your own language using the runtime API. The function can then go and perform whatever it needs to do. Update a database record, return something to a client, talk to another API or endpoint that exists somewhere, send its output to another service. Lambda is a compute service, so itself is running on top of underlying compute resources. Yes, there are actually servers in serverless, but you don't have to think about them. You don't have to manage or scale them. So this is the basic architecture diagram for a serverless web application. We have a service called AWS Amplify Console, which you can use as a hosting platform for single-page applications and static assets such as HTML, CSS, and various JavaScript frameworks. You can use a service like Amazon Cognito to manage user authentication for your customers with a lot of functionality. Lastly, where we're going to be spending the most of the time today for observability is looking at the API backend for this application. The client makes calls to our managed API service, API Gateway, which invokes our Lambda function, which includes our business logic, which then does some processing and in this case stores information in DynamoDB, a NoSQL database. So first up, we need to recognize that there's no such thing as an application that never fails, one that always keeps on running whatever happens. As Amazon's CTO Werner Vogels often loves to say, everything fails all the time. We must assume we will need to deal with failures, and often exactly when you don't want them to happen. Now, looking at a traditional application stack, there were a whole number of layers in the stack you had to monitor or do observability for, from the network, storage, physical server hardware, all the way up through many abstraction layers of virtualization and operating systems, eventually to your application itself and some business outcomes. I've spent 25 years as an infrastructure engineer and a lot of time setting up monitoring and alerting for many of these components across the many layers. But luckily, if you're building serverless applications, we now take much of the burden off your shoulders, so you don't have to monitor many of the layers yourself. This becomes AWS's responsibility. The layers are still there, but we look after the physical infrastructure, virtualization and operating system layers, and the platform runtime. You can now focus more time on your business logic as part of your application and data. And so we come to the concept of observability, which is getting a lot of buzz in the industry at the moment, meaning a lot of things to different people. The simple idea is to do more than monitoring, just waiting for things to break. While monitoring may be seen as making sure what you monitor is working okay, observability is having more visibility into the system as a whole. Not just knowing you have a problem, but understanding why it is happening and hopefully also creating a path to resolution. Observability helps to combine the outputs your application produces, which is instrumentation data you gather about your application across all the different services, with better debugging along with good testing, all built into your software development lifecycle. Good observability means you don't have to add extra instrumentation to understand an issue. I like to think of it as being able to look at the big picture from outside looking in, to be able to work out everything that's going on in an application by looking at its outputs. Hopefully also being able to then spot the unknown problems. So it's monitoring more than just failures. Is your application actually performing as expected? Even if your monitoring dashboard is all green, are your customers getting the user experience you want to give them and that they expect? What's the usage of your application? How many people are signing up? What parts of your application are hitting limits or congestion? Is the usage expected? What about business relevant information? What's the revenue being generated? From what geographic region are you seeing the biggest growth? How would an outage of a component affect your business? What trends can you visualize? What tactical questions do you need to ask? When understanding what observability means in the larger sense, it's how your business and culture think about performance, failures, and collecting data. It's certainly worth your time doing some reading and finding resources applicable to your business and how you operate. Observability tooling consists of looking at 3 pillars: metrics, logs, and traces, and importantly, providing contextual linking between these 3 pillars. You can see the definitions here. Metrics gathers numerical data about the things you want to track for your application. Logs are time-stamped records of events. Logs may have metrics included with them. And traces are a single user or transaction journey through a number of separate applications or parts of your application. And as I mentioned, contextual linking is how all 3 of these are interlinked. Failure is something that is embraced. Failure modes are actually designed as part of the application during the software development lifecycle. You need to collect enough data to actually understand the system. If data is missing, you could have gaps in your visibility. Using the rich data is then super important for debugging and quicker troubleshooting. And moving to testing in production, not just in an isolated test environment. With smaller components released more often, testing changes in production becomes even more important. AWS has 2 main services to help with observability with a number of capabilities: Amazon CloudWatch and AWS X-Ray. CloudWatch is one of the oldest services at AWS, collecting monitoring and operational data in the form of logs, metrics, and also events. There are nice dashboard views across your application, and you can set up alarms to alert you if something is important. AWS X-Ray is the AWS tracing service with analytics and a service map. It helps developers analyze and debug production applications, helpful for multiple distributed components. And of course, with CloudWatch, this all happens at massive scale. Yes, 1 quadrillion, which is 1,000 trillion metrics observations each month. CloudWatch processes trillions of events each month and 100 petabytes of logs ingested. CloudWatch runs monitoring for all of AWS and Amazon.com, as well as our customers. It's huge and can certainly handle your load. But CloudWatch and X-Ray are not your only options. We have a broad partner ecosystem with some amazing monitoring and observability products. Some have further integrations to other parts of your stack and software development lifecycle. I wish I had the time to show you what they can all do, but just like a Lambda function, I can't go on forever. Before we look at the individual features, let's see how a typical workflow would look like when you're troubleshooting an issue or wanting to ask a question about your application. You may start with a question, or if something is wrong, you receive a notification through an alarm. You would then go to a service map and visually observe the application environment for anomalies. Then see the traces of that particular component and narrow down the specific set of traces that have issues. You could analyze the traces if necessary and correlate the traces with individual log lines. You can dive deeper to get application-specific logs correlating to the traces to help identify the root cause easily. This workflow isn't necessarily one way though. You can start with some sophisticated log querying to find out, for example, what your error rate is. So, as I previously mentioned, we're going to be focused on how API Gateway Lambda, and DynamoDB as the basic building blocks of a serverless application and how to think about observability for them. First pillar to look at is metrics. What metrics you have available without even doing anything yourself, other than building your application, of course. CloudWatch comes with a number of standard built-in metrics. These are automatically generated when you use Lambda, API Gateway, and many other serverless services. I've highlighted some of the important metrics to get started with when components are unhealthy. Lambda has 13 built-in metrics covering various invocation, performance, and concurrency metrics, so you can easily see how many functions are executing, how long they are taking, and what function errors you may be getting. There are also some metrics for seeing how many functions are running at the same time, some only populated if you use provision concurrency. API Gateway REST APIs give you 7 metrics showing you how many API calls you're receiving, along with error counts and cache details. HTTP APIs and WebSocket APIs give you 6 metrics. With DynamoDB, you get a whole bunch of metric data out of the box. This depends on what functionality you use, what indexes, what replication you set up, for example, that you can set up for DynamoDB. Remember, these are generated automatically, so you don't have to set up anything for yourself. This is just part of the package when using managed services. In the AWS Management Console for CloudWatch, we can see a number of ways to view these built-in metrics. You can use the per service dashboard to view the automatically generated metrics for a single service. In this example, Lambda, and see metrics such as the number of invocations and how long they ran for all the functions in this account in a region. I could select API Gateway and see API Gateway related metrics. I can also select a cross-service dashboard to see the important standard metrics for all services in my application in a single page. And here we see API Gateway and another serverless service step functions. So it's really easy to get a basic view of your application without having to do anything by viewing the automatically generated standard out-of-the-box metrics. As helpful as they are, though, the built-in metrics are often not enough. You likely need more visibility into your application and not just at an infrastructure or application level to get that observability you're looking for. You may need to track your business and customer metrics. How's your application performing against business goals? Are you generating the revenue you need? Are you getting enough people signing up for your awesome service? What's the customer perceived latency? Operational metrics are also important for observability. How often can you safely deploy? How long does it take to recover from a failure? How often are you having to wake up your developers with an issue? What about other Lambda errors like caught exceptions which are not counted as errors? How are you handling them? What if you want to create metrics for a particular category or environment, another dimension? This is why you need custom metrics. These are the metrics that are specific and important to your application. And you can generate custom metrics by instrumenting them in your code. Within your Lambda function code, you can use the built-in capabilities of the AWS SDK to call the CloudWatch API. You can use the put metrics data API call to write any custom metric you want. And this has been improved recently with the embedded metrics format, which I'll cover shortly. So once we have our metrics created, we can head to the CloudWatch console metrics section and can see and visualize all the built-in and custom metrics that have been generated for our applications. We can graph and plot to our heart's content. Here I've plotted a graph showing a custom metric for file uploads over the past 5 minutes. Okay, I'll admit it's not a particularly busy app, and you can also decide to display that as a number rather than a graph. And the console now has a handy metrics explorer to find metrics by resource properties and tags even easier. So now we're going to take a deeper look at logging, and structured logging in particular, and how this can be helpful. CloudWatch Logs generates logs for a number of AWS services. For API Gateway REST API logging, you can log error and info, either set globally in the stage or for individual methods, with some additional options available. HTTP APIs and WebSocket APIs have a number of logging variables you can use. For Lambda, you can log directly from within your application code using your language equivalent of console.log in JavaScript or print for Python to send a message to CloudWatch logs synchronously. You can also create JSON structured logging using either the putMetrics.data API calls or the new embedded metrics format, and this includes function invocation information. Once you have your logs being created, you can do a number of things. Filter them, now with 2 subscription filters per log group. You can create metrics from them or even ship them off to somewhere else for analysis. So the basic Lambda console.log logging appears as a text line in the logs, but it's difficult to correlate and you often have to build complicated systems to then extract real metrics from the logs. So to help with this, AWS has released the embedded metrics format to publish logs using a specific format. This allows you to embed custom metrics, which may be part of the event payload, alongside more detailed log event data, and this gets sent asynchronously rather than synchronously without an API call. These then get automatically exported as metrics without the need for any additional processing on your part, and can then be consumed for dashboards and alarms too. There are open source client libraries available for Node and Python, and Java has recently been added too. You can see the structure of the JSON embedded metrics format log here. You can see this includes the Lambda function invocation information. The metrics are bundled to a namespace and a dimension, which just helps to organize them, along with some metrics from the actual event. In this case, the price and the quantity as a unit. This log entry with included metrics is automatically exported to CloudWatch metrics, so you don't have to build a whole process to parse the logs and extract the metrics yourself. And once you have your metrics created, you can create some impressive dashboards for your platform and business metrics. Time now to look at Amazon CloudWatch Logs Insights, which is a super useful part of CloudWatch Logs. CloudWatch Logs Insights is an interactive log analytics capability for CloudWatch Logs. This allows you to search for and visualize data based on anything in structured logs, including the metrics. You generate and run queries using a purpose-built language. You can query across up to 20 log groups and save queries for running again later. For this simple example, we may just want to see all errors. We select the Lambda function log groups in the console and then run the query to see the results. But we can also do more complex queries, even looking at built-in platform metrics, say looking at the most expensive Lambda executions. This query creates a report which gets the request ID and then also retrieves and sorts by the build duration, displaying the first 100 results. You could use this to find out which Lambda functions are taking longer than expected and maybe investigate further for performance issues. You could also use this to know where you can look first to save costs by finding your most expensive Lambda executions. And this general query gives you information on Lambda performance and aggregates the data per 5-minute time period. You can find out the duration information for one or a number of functions. The number of invocations with total, average, max, and minimum duration, and then duration for P90. You can use this to work out any performance issues you may have over time. Log Insights has really powerful searching capabilities. So we have all these logs and have some standard and custom metrics set up. We would likely want to alert on them, either to know when something is going wrong or also to find out if we've maybe hit some kind of business number that's interesting. Alerts don't always have to be only for issues. So for a simple example, I can set up an alarm to alert on a custom metric. To create an alarm, I set a metric from my application. I change the statistic, in this case, to alert on the sum over 5 minutes. I want a static threshold to alert when there are lower than 5 over those 5 minutes, and select to email to an existing SNS topic, which emails me when the alert is triggered. Alarms can also be created using anomaly detection rather than static values. This works if there's a discernible pattern or trend to your application. Anomaly detection looks at past metric data and uses machine learning to create a model of expected values. You can then alert if the metric falls outside the band of normal values. So, onto the third pillar of observability, which is tracing. X-Ray is a distributed tracing solution from AWS, which provides an end-to-end view of requests as they travel through your application. It can also show a visual service map connecting your application's underlying components. You enable X-Ray for various AWS services, including serverless ones such as Lambda and API Gateway. For Lambda, you enable X-Ray by checking View Traces in the console or using AWS SAM and then instrumenting your application handler code to add tracing data. For API Gateway REST APIs, X-Ray adds a tracing header into HTTP calls, which then flow into your Lambda function so you can know which API Gateway call is associated with which function invocation. You enable X-Ray tracing per stage in the console or also easily in SAM. X-Ray receives data from services as segments. These are then grouped into traces. You can add your own custom data to the traces. This helps to add your custom application information such as a customer or payment ID, for example, to your traces. Once X-Ray is enabled, this automatically starts to collect tracing data for your functions and APIs for the subsequent requests. So when a trace is created, this is what it may look like. You can see this is a Lambda function. You can see the exact time it takes for the Lambda service to run your function initialization code. And this example is putting an item into S3, and there is some kind of error it has picked up, which you can go and investigate. And another part of X-Ray is X-Ray Analytics. As the name suggests, it's a way to do deep dive analysis of your traces. You can see a histogram of performance, and you can use it to, say, compare two time series, and then see the heat map updated with a comparison to see any differences. You can also view the divergence across values, which may be useful to you. And you can also use your custom annotations, such as usernames, and really dive deep. There's a lot of information you can add to your traces with the X-Ray SDK. At reInvent 2019, we announced CloudWatch Service Lens. This ties together CloudWatch metrics and logs, as well as traces from AWS X-Ray, more closely to give you a complete view of your application and their dependencies. This enables you to more quickly pinpoint performance bottlenecks, find out what's wrong, and have a better idea of how users may be impacted. So let's take a look at what Service Lens looks like. Heading into the CloudWatch console and then to Service Lens and the service map, which is automatically created from all the individual services collecting X-Ray traces. It can be busy in a bigger account, so you can jump to an individual node, such as an API Gateway stage, or you can set up an X-Ray filter group to group application components together. I can then look at how different components are connected together, and the size of the icons shows the number of requests, which would be color-coded with any high latency and errors. In this example, selecting a Lambda function shows some immediate info, such as average latency, requests per minute, and any faults. Selecting the function brings up some more information in graph form, plotted over time, and I could use this as a first step to start investigating. Now, how Serverless Lens shines is directly from here. I can jump to view the logs or the dashboard for this function, or view the traces gathered for this function. I could jump directly to X-Ray Analytics if I wanted to do some deep dive comparisons, and here I can see the trace information. I can filter by a number of ways, such as trace status, or looking at the user agent, or response code, or other things. Here I'm interested in seeing how my Windows clients are performing. So I can easily add that to the filter to see all traces only applicable to them. You can get very sophisticated with your filterings. So I can see that there are 5 traces and then look at the response time distribution for them. I can further filter my selection to narrow down to the P95-99 response time. Adding this to the filter, I can now see the individual trace or traces matching the filter. Selecting this individual trace, Service Lens loads up the trace summary. This then shows the segment timeline, which is a very handy way to see the time spent and also highlight some errors at each individual stage for a request as it flows through the components of my application, showing the exact time spent. And this will go through API Gateway, the Lambda service itself, the Lambda function, and the individual requests to DynamoDB, seeing each call's duration. Heading down to the bottom, another super useful feature is jumping to or viewing here the log insights query for my filter. I can see API Gateway execution logs as well as the Lambda logs all within a single place. Service Lens makes it really easy to correlate traces, logs, and more for my serverless application. Something else we haven't covered, but still fits into observability feedback loop, is testing. Canary testing is testing out a new part of your application when it's rolled out to a small subset of users, or even doing testing with no external users yet. CloudWatch Synthetics is a service to monitor application API endpoints more easily. You create canaries to run tests for things such as availability, latency, or even dead links. Synthetics can let you know when it finds a problem so you can discover issues before your customers do. So back to our workflow. We can now see some of how CloudWatch and X-Ray services can be part of this workflow. CloudWatch Alarms receives the notification. We can use Service Lens to view the service map to identify our line of inquiry. This can lead us to X-Ray to view specific traces. And we can use X-Ray Analytics to dive even deeper for analysis or comparison. And Log Insights is great for querying logs and asking questions even independently of traces. So a new functionality we've recently launched at AWS is called Lambda Extensions, which is a new way to integrate Lambda with your existing tooling, particularly for observability. Lambda Extensions makes it much easier to integrate your existing tools deeply with Lambda with no complex installation. You plug extensions into your Lambda functions. Extensions can then pull data out of the Lambda service about function invocations. You can see more details on how the service runs or change some aspect about how the function starts up. For observability, this means you now get more diagnostic data before, during, and after function invocation, and extensions can also auto-instrument your code. There are many other use cases, such as config or secrets management, along with some security capabilities. You can drop an extension into your environment by adding a Lambda layer to your function and adding some configuration information via environment variables to use or consume the capabilities of an extension. You can build your own extensions using the Extensions API to hook into the Lambda lifecycle. And extensions can use the new Logs API to get logs data directly from the Lambda service. There's a lot more information about extensions available, so use the links to read all about it. There are a number of extensions and integrations already available from AWS and our many partners, and there are more to come. Extensions really makes it easy to use your favorite tools with Lambda. Another exciting new capability of Lambda is being able to create functions defined as familiar container images. You can use your existing familiar container tooling to define your Lambda functions, which can contain your observability tools. You create container images, which you then upload to Elastic Container Registry and build the function using the images. When your function invokes, Lambda starts and runs the container you've defined. This means you can now use familiar container image building constructs to add observability tooling to your Lambda functions. Container images still need to be event-driven applications, as I explained earlier. Again, there's a lot of information about this announcement, so follow the link to read more. Another useful set of tools for removing the heavy lifting with observability is the open source Lambda Powertools, which AWS and the community has created. This allows you to more easily add logging, tracing, metrics, and Lambda-specific information to your Lambda functions with some helpful utilities added too. This is currently available for Python and recently Java, so take a look and also consider contributing to extend the use cases. So, to summarize, we've covered a lot. We've covered how observability has evolved from monitoring, a culture to gather the right data so you can observe the inner working of your application from the outside. I then went through the many capabilities of CloudWatch and X-Ray and how they can be used with observability. Looking in more detail at the embedded metrics format as a powerful 2-for-1 to give you even better metrics from your logs. How Log Insights can be used for powerful querying, how Service Lens can be used to more easily hop between metrics, logs, and traces. This helps to round out how I like to think of observability, getting the data you need and being able to act quickly on it. And then looking at the exciting new functionality with Lambda extensions, as well as container image support to more easily use your observability tools with Lambda. For plenty more information, we have a super aggregation site called serverlessland.com with lots of resources, blogs, videos, workshops, and learning path. Everything about serverless on AWS. Thank you. I really appreciate you taking the time to watch today. and hope I was able to show you how to help bring observability to your serverless applications. Please don't hesitate to contact me if you have any questions.